Question 2 is another nice start to this when you've got to actually use the binomial expansion. It's one of those things which you just have to keep practicing over and over again. Now, the binomial expansion, we need it to start with a 1 here, so we're going to have to take out the factor of 4. We've got 4 lots of 1 plus 5 over 4x, and all of that needs to be to the power of a half. The bit that people will go wrong on that is it's 4 to the power of a half, so we've got 2 lots of 1 plus 5 over 4x to the half. Now the expansion, when you're working this out, it's 1 plus n ax, and then I've got n take away 1 over 2, and I've got ax squared. It doesn't ask me to go any further, so let's keep going. So I've got 2 lots of all of that. So it's 2 lots of 1 plus, here I've got 5 over 8. Here there's a minus there, so I've got minus, I've got 5 squared there, it's 25. I've got 4 squared, which is 16, and I need to divide by 2, so 16, 32, 64, 128 there. And multiply that out one more time, gives me 2 plus 5 over 4x minus 25 over 64 x squared. And that's similar to what they were asking for here. So we've got the k is minus 25 over 64. Part B, so there's 4 marks for that. That's quite nice. Part B says, put in the value x equals 1/10. I'm going to put it into 2 different places. First of all, I'm going to put x equals 1/10 into here. When I put x equals 1/10 into there, I've got 2 plus 5 over 4 lots of 1/10 minus 25 over 4 1/10 squared. Now, sorry, I've just been getting my calculator. That makes 543 over 256. And as a decimal, that's 2.121. Now I know that that's not root 2. That's what this thing here gives. The other thing I've got to do is put this 1/10 into this bit here as well. So if I put 4 plus 5 over 10 to the power of a half, so that is 2.5, isn't it? That's 4 plus 5 over 10. So that's the square root of 2.5, or 5 over 2. Sorry, not 2.5. That's the square root of 4.5. Square root of 4.5, so I've got the square root of 9 over 2, which is 3 over root 2. Still not quite helpful, so what I'm going to do is I'm going to rationalise that denominator. So I've got, so that gives me 3 root 2 over 2. That tells me that that is 1.5 root 2's, and this, well, this here is 1.5 root 2's, and so root 2 is going to be equal to 543 over 256 times by 2 over 3, and that gives me 181 over 128. And again, I can check that on the calculator. That works out to be about 1.41, which is what we expected root 2 to be. The last line is always the easy bit at the very end. Why is this valid? Well, this is valid because the whole thing works. Where's the expansion? This bit here works when 5 over 4x is less than 1. It works if this bit here, always that bit there, 5 over 4x is less than 1, or the modulus of that is less than 1. So it works when x is less than 4/5, and so x equals 1/10 is valid then because 1/10 is lower than 4/5.